Who can tell me what is slope-intercept form? SI form. What does it look like? What do we say it is? Travis?
It's y equals mx plus b.
Good. Y equals mx plus b. And this is just a form, right? If I want to know if something is slope-intercept form, I want to look at it and say, does it look like this? Or where m and b would be numbers? And what did m represent for us? M was the slope. Good. So let's see if I can't get a pen that works. M was our slope. And what did we say about B? Good. Thank you. It's the y-intercept. Okay. And what we want to focus on is, well, let's do two examples like this. Let's do it like this, okay? Let's do two examples and say, if I tell you, so let's write the equation. If I tell you that the slope is negative 2/3 and y-intercept is -2, what would the equation be? I want to write it in slope-intercept form. What would the equation look like?
Sort of like don't you like plug those in for the m and b?
Yeah, good. So Lacey, can you read the whole equation then for us?
Y equals -2/3 x. Oh, I thought you said. I thought you said.
It's all right. Go ahead, Lacey. Finish up. He said negative 2/3 x plus -2. Good. And I like that you said plus -2 because it's a plus here. And I'm just going to write it as -2. Okay, because plus -2 is the same thing as subtracting 2. Okay, but I like that you found that this is a -2 in there. All right, cool. So let's do one more that's kind of like this. Let's do, say that we're given this now. If I give you these 2 points, let's call it 0, 4, and I don't know, how about -1, -2. What if I only give you 2 points? Well, let's look at this first point. What do we know about this first point? Yeah, good. This is the ordered pair for a y-intercept. This point here is the y-intercept. How do we know it's the y-intercept? Travis?
Because the x is 0.
Very good. Yeah, good. Okay, and this is because x is 0 here, right? That's how we know it's the y-intercept. So I've got the y-intercept, so I can say the y-intercept here is 4. That's what Lacey was saying. What else do I need to be able to write this equation? Go ahead.
You use rise over run to solve it for the slope.
Sure, I can use rise over run, and what's the formula that we have to find the rise over run? Do you remember? Good. y2 minus y1 over x2 minus x1. So we also need our slope. So we have our y-intercept, and we need to find the slope. So we use the slope formula here. What would my y2 be? Good. Yeah, we'll start with the last point here. It's -2 minus y1 would be 4 over negative 1 minus 0. What is negative 2 minus 4 more? Yes, good. Negative 6. Sorry, I'm trying to get it so you can still see everything. Negative 6. And negative 1 take away 0 is negative 1. Can we simplify this at all? What's negative 6 divided by negative 1? Yeah, it's just a positive 6. So let's write the equation. Y equals what?
Y equals
6x plus 4. Okay, is that tricky? No, not really. And we can't make it a whole lot harder. We are going to do something like this where we take the next step in a minute, but I want to just practice writing the equations in slope-intercept form when I don't give you just points. So let me show you what I mean. What if I give you something like this? Slope-intercept form is the equation for a line. Okay, so if I give you if I give you an equation, and I say that I give you 3x plus 2y equals 12, is it linear? Is this a linear equation? Yeah, how do we know? Because it doesn't break any of the rules, right? It doesn't have any exponents. I don't multiply x and y together, and I don't have a variable in a denominator. So yes, this is linear. And if it's linear, I know I can write it in slope-intercept form. What do you notice about this and slope-intercept form? What's the difference between the two? Travis?
The y variable has a number.
Good, yeah. In this one, right, the y has a number in front of it. Okay, so let's just remind ourselves here. Slope-intercept form looks like this. Travis says, yeah, in this one, there's a number in front of y. I don't want a number in front of y. So I know I'm going to have to deal with that. What else am I going to have to change about this equation? So what we're saying is that since x and y are being added here, I want to set them equal and have them on separate sides. So let's start and say that our goal here is to get y by itself. Okay, that would, when I say get y by itself, it means on the own side of its equal sign, and we're going to get rid of that number that Travis was talking about. You remember when we solved like literal equations? Where I gave you like the area of a triangle is 1/2 base times height, and you had to solve for the height. That's the same thing that we're doing here. Okay, so you've done all this before, but let's do one here. Three x plus 2y equals 12. So let's do this. Let's say, what am I doing to y? What's the first thing that happens to y? I'm multiplying it by 2. Good. What's the next thing that I do after I multiply it by 2? and then you're adding 3x. So how do I undo this? Good, so I'm going to subtract 3x and divide by 2. And we're going to work backwards here because those are our inverse operations. So the first thing that we're going to do is subtract 3x. And if I do it to one side, really got to do it to the other. I'll split my equal sign here. That should be enough. That'll give us 2y, because these 3x's cancel out, is equal to, and I'm going to leave my x first here, because that's how it goes. So it'll be negative 3x and a positive 12. Just separate that so I know it's not part of my equation.
Why did the same thing?
And then what would I do next? Good. And I'm going to divide the 2 on both sides, which means I divide it everywhere. So here's how I'm going to divide the 2. We'll write it out step by step, actually. I'm going to divide the whole side by 2, which means that y is equal to negative 3x divided by 2 plus 12 divided by 2. Okay, do you guys see what happened here? I was dividing the whole thing by 2, and since I'm adding, I can divide each piece by 2. Well, let's simplify it this last step here. Y would be equal to, can I simplify negative 3 over 2? Does 2 go into 3? No, so I'm going to leave that as negative 3 over 2x. And what's 12 divided by 2? 6. Is this in slope-intercept form now? What is my m? Yeah, very good. Negative 3 over 2. And what would b be? 6. And that's all we're trying to do with these problems, all right? So let's try 2 more, and then I'll let you work on some HRWs here, and we'll be good for a minute. Okay, so let's do another one. Let's do another one that looks like this. Let's say now I've got negative 2. Oh, I did 2 again. That's all right. Negative 2y plus, let's go with 6x equals 13. We'll do one more like this, and then a slightly more difficult one. What are we doing 2y? Good, I'm multiplying by negative 2. And then what? Adding 6x. So to undo this, what do I need to do? Yep, divide by negative 2. Good. So to undo them, the opposite of adding 6x is subtracting 6x. And the opposite of multiplying by negative 2 is dividing by negative 2. So we can draw our little river here again. And we say that the first thing that we need to do is start from the bottom and work up. So I'm going to subtract 6x from both sides. I'm not doing a good job of giving myself enough space. But I'll skip a line here so I don't run into myself. maybe I can fit it. We'll fit it in. Negative 2y is equal to, again, I'm going to put the x term first, and it's a minus 6x and a positive 13. And then we said we need to divide by the negative 2. And I'm going to skip that step. I'll do that. This is divide by each piece by negative 2. I'm left with y is equal to, what is negative 6 divided by negative 2? Drew? Positive what? 6 divided by 2. 3. There you go. I wasn't sure if that was what you said or not. And then positive 13 divided by negative 2. It doesn't go in evenly, does it? But what's a positive divided by a negative? It'll be a negative. How many times does 2 go into 13? 6. And then not completely, so we'll call it 6.5. Okay. Cool. Is this in slope-intercept form? And the answer is yes, because you're circling it, Mr. Cruz. All right, let's do one more here where it gets a little bit unique. And this is actually a different form of a linear equation that we're doing in just a few minutes. Let's give it to you like this. Let's say that I've got y minus 6 is equal to 1/3 x plus 9. And you might recognize an equation like this. This equation is actually in what we call point slope form, and we're starting that today as well. So notice a couple of things here. Pay attention to what happens to this 1/3, and then we'll talk about what happens with these numbers here. Okay? So let's think about what we can do to make this into slope-intercept form. Are there any parentheses in slope-intercept form? No. So how could I go about getting rid of these parentheses? Yeah, very good. I'm going to have to use the distributive property. So I'm going to distribute first. I'm going to distribute this 1/3 to the x. And I've also got to distribute it to the 9. So let's do that. I leave this y minus 6 alone. And I'm going to skip a line so I don't run out of space. Y minus 6 is equal to, what's 1/3 times x? It's just 1/3 x. What is 1/3 times 9? Very good. Yeah. What is 1/3 of 9? 3. So 1/3 times 9 is 3. Excellent. Well, now how do I get y by itself? Drew? Yeah, cool. So we add 6. That'll leave us with y equals 1/3 x plus what? Plus 9. Is that in slope-intercept form? Yeah. Yep. What's my slope? 1/3. Just the 1/3, right? Not the x. Notice the 1/3 started here. In point slope form, this will be your slope. Cool. That's 20 minutes of notes. I'll let you finish writing that one, and then let's give you some time to work.